Okay, this is the lesson on perpendicular lines. This is quite an important one because this little short, brief skill comes up in many different places in higher maths. So it's an important one to get right. We're going to talk about how two lines can be perpendicular to each other and how we prove that and how we use that. So let's have a look down here. We've got our notes. Something to highlight here would be the word perpendicular to begin with. Hopefully you know what that means, but the word perpendicular means that two lines meet at right angles to each other. So we're talking about, let's hope that this straight line tool works. So, yep, there's a line there. And one that comes down and meets the other at 90 degrees. That means that these two lines are perpendicular to each other, so they meet at 90 degrees. It's said in higher maths, and all maths I should say, that if perpendicular lines have gradients m and then m with this wee symbol underneath, if these two gradients, if you multiply them together, you should get -1. That means that these two lines are perpendicular to each other. If you multiply the two gradients together and get -1 coming out, the lines are perpendicular. So there's a simple rule that comes off of this, and that is, well, I call it perping, but you're basically flipping and then changing the sign. So if we find the gradient in one of the lines, if we found the gradient was m equals 2/3, and we wanted a line that was perpendicular to that, you can see the wee symbol there, or the short word perp, you flip it and change the sign. So positive 2/3 becomes -3/2. Flip it and change the sign. It's as simple as that. So if you're going to perp a gradient, that's what you do. Okay, a couple of things to remember. This is, the rule cannot be used if you're talking about lines which are parallel to the x-axis, better known as horizontal lines, or parallel to the y-axis. They're undefined. You can't use the rule. You have to remember that perping doesn't apply in the same way. So keep your eye out for these. The gradient is 0, y-axis, perpendicular lines. You'll see a wee example coming up later. Okay, the first example that we're going to have a look at is this one. Really simple skill. We'll find the gradient between T and S, and then we're going to find the line perpendicular to ST, and we'll use this perping skill. So, first of all, the gradient between T and S. And it doesn't matter which way you go. We can do y2 minus y1 over x2 minus x1, and it doesn't matter which one comes first. So I'll just go as it sits. 5 minus -2 over -4, take away 1. That's 7 over -5. We've got our final gradient. Maybe I should call that -7/5. And the perpendicular is, I just write the word perp, and we flip it and change the sign, so that becomes 5/7. Simple as that. To get an idea of what's actually going on there, if I draw a quick wee sketch, S is about there, T is about here. You've got a line coming between those. The perpendicular line will come off somewhere in there, or anywhere really, and that's the gradient 5/7. Okay, example 2. So I've done a quick wee sketch to help us with this one. There it's there. We have to show that the triangle is right angled. We can do this by finding the gradient of MO and then proving that that's perpendicular to the gradient of OP. So let's find the gradient of MO first of all. That's y2 minus y1 over x2 minus x1. Again, watching for double negatives. That's -9/3, which gives us -3. Just have a wee check in the diagram. Yep, that's a negative gradient, so that might be correct. Let's find the gradient from O to P. y2 minus y1 over x2 minus x1. That's 4 divided by 12. That comes out as 1/3, and there we go. You've got -3 and positive 1/3. Now, here's what comes into play. We can now say, since the gradient of MO multiplied by the gradient of OP equals -1, the lines MO and OP, I should say, are perpendicular. Therefore, triangle MOP is right angled. Make sure you tie it back to the question, state whether it is right angled or not. Okay, so that's how we will go about question 2. Here are some questions for you to have a go at. You can pause it and then come back and I'll give you the answers. Okay, the answers for the first one is the perp gradient is 3. Flip it and change the sign. The perpendicular gradient would be -3/5. For this one would be -1/4. And for D, this is one of these circumstances where, think about what that means. That is a horizontal line, meaning that if we perp that, we're going to get a vertical line, and that means that the gradient there will be undefined or infinite. And for question 2, the answer you're looking for would be perpendicular gradient is -7. The extension question as well, give you a second to have a go at that. The gradients are Q is 4/3 and PM would be -3/4. And then down here, explain why the triangle is isosceles. Well, you've proven that you've got this situation going on. That's the midpoint. These are perpendicular to each other. Therefore, the triangle has to be isosceles because that's the midpoint. It's perpendicular. It doesn't matter where you put that point up there. It will still be an isosceles triangle. Okay, now go and try exercise 1D. That's from the textbook if you've got it. Otherwise, that's us for just now.